Hello, F-sharp. Welcome back. We are continuing our exploration of functions in F-sharp. This is now the third video in the series, and that's because F-sharp functions are integral to how F-sharp functions. But I'm like, terrible joke, sorry. And what we're wanting to cover this time is partial application and closures, what they are and some of the implications around them and how it causes us to work with functions inside the F-sharp language. And so I'm going to define a very simple function here. So let my function, and I'm going to have this take three parameters, right? It's going to take a B, and a C. And then at the end of the day, what it's going to do is go A plus B plus C. Incredibly simple example. Now, type inference is telling us like, hey, these are all integers. And so like, hey, this function, my function, is a function that takes an integer, then an integer, then an integer, then it returns an integer. Okay, and now let's start talking about partial application. Because this is one of those things that if you're coming from a C# background, a more object-oriented background, this will probably be the thing that's like, whoa, like what the heck is going on there? So, or maybe it's simple for you. I don't know. So what we can do, my other function equals my function, then 1. What am I doing here? Well, my function is an F-sharp function. And one way you might read this, and you might want to review the video 2 videos ago now, I believe at this point, talking about F-sharp in curried form versus tupled form, because now that curried form is going to mean a whole lot more. One way that someone would interpret this, and this is how I interpreted it when I began F-sharp, is I see this function signature, my function. It's really nice. The Ionide plugin for VS Code is also giving me what the type signature is here. So that's really fantastic. But I'm also going to hover as well, saying, hey, you have my function. And I naively thought, oh, well, my function is a function which takes an A, a B, and a C, and then returns an int. That sentence may sound correct. It is profoundly wrong. It is profoundly wrong. And I'll repeat it. And so like, hey, my function is a function that takes an A, a B, and a C and returns an integer. So it takes an integer, and an integer, and returns an integer. That is not what is really happening. What is really happening is it's saying, hey, my function is a function that takes an integer, and returns a new function that is a B integer, C integer, then an integer. So when you see this, what you should see, these arrows are really significant because what they are saying is, hey, you can give me an integer and I am going to return something that is the rest of this arrow series. And so that's what my other function is. Whereas I took my function and I filled in the first value. And so what you'll see is that my function, this type signature that you see out here, was an int, 4 ints. My other function though, and I'm going to go ahead and put this on a new line. My other function though, what is that? Well, this is an int, then an int, then an int. These are 3 ints. And because what has happened is I took that function and I filled in a value and I got a new function back where the value for A has now been filled in for me. And I could then say, let yet another function, and I am going to take my other function and I'm going to fill in yet another value. And so what's happening is this is a function that returns a function. I can fill in a value and I'm going to get a new function back, but one of those parameters has now been filled in. That's what happened here. I filled in that first parameter. What I did here is I took the result of my function and putting that 1 as that first parameter, which gave me a function back, and I filled in yet another parameter. And now I could say, hey, well, let my last function equal yet another function, 3. Now what's happening, though, is that the type inference is saying, no, my last function is just an integer. It's just an int. Because what has happened is each time we took the function, we filled in a parameter, but it gave us a new function back. It's just that now some of the values have been filled in for us. And so this is the idea of partial application. We can create a function which has this very generic functionality and then fill in some of those values, but then still get a function back. And so let's actually run this code and see what we get. So here I go. My function is like, yep, you've defined a function, A to B to C to int. So it's int, 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 int. And then I'm going to come down here. I'm going to run my other function. Like, yep, you got another function back. It's just that now that first value has been filled in with 1. Yet another function. I'm going to take the result of the previous one and fill in yet another value. And now I'm going to do the final one. And the result is 6. And that makes sense because, 1 plus 2 plus 3 is 6. And so it's the idea of this is the actual logic. Like this is the thing that's actually doing the work. These other pieces are just taking that functionality and filling in parameters for me is a way of thinking about it. This seems really simplistic. This is like, Matthew, this feels kind of contrived. Like, why would I use this? This doesn't seem very useful. Well, let's unpack a little bit about what we can do with this. Like, okay, let's say I need some, I need a logger, right? And it's like, hey, let my logger, right? And it has like logging params. And then what you do is like, hey, well, I want to fill in some logging params, but then I want to say like, hey, my message, I'm going to say like, hey, this is a string. And then I want this thing to go print something out. So it's going to return a unit. It's not actually going to return anything. So so now I could say, okay, well, I don't want to have to pass logging params all over the place. What I could do, and I realize that there's like more sophisticated ways of doing this. I'm just kind of coming up with a contrived example, so don't judge me. But it would be a real hassle to, and let's say like, hey, log something. It'd be a real hassle if we had this function which is, hey, log something, and having to be aware of these logging parameters everywhere we wanted to call this. That would be obnoxious. What we can do with partial application though, and I'm just going to have this return unit, like pretend there is cool logic here, smiley face. So pretend that something like cool has happened there, but it needs the logging parameters to be able to do that. Now, like I said, it'd be a real hassle to be passing these logging parameters or configuration like all around your application. So what we can do though is say like, you know what I'm going to do instead is I am going to say like, hey, I just want my code to be able to have a function it can call. You give it a string and then it does the work it needs to do. What I could do is say like, hey, let my logger equal log something and then the params. And what this, okay, I'm gonna do something silly and just say like, hey, I'm gonna say this is just a string for now, and pretend that I am passing in parameters here, smiley face. So what I've done is say like, hey, I took this function And for this function to actually do the work it needs to do, it needs to be aware of more values. It needs to have some amount of configuration built into that function for it to do its job. But I don't want to pass those around everywhere. So what I can do instead is like, okay, I'm going to take that function and I am going to call that function with just the configuration parameters. And what I get back and you can see this in the function signature, is like, hey, my logger is now a function. It takes a string and it returns unit. And so what I've done is I've taken this one little piece of logic and I've essentially parameterized that function by filling in some of the values for it. So now I can pass my logger around inside of my program, and it's going to have all the parameters baked into it. Now, there is an important implication here. That means my logger is an object. It is an actual thing. It will exist on the heap, most likely. There's a possibility that something gets inline, but in this case, I really don't think so. I just haven't read the depths of the compiler yet to be able to say that for sure. But the idea with the partial application is we could take some really sophisticated code and fill in the values it needs to do the work it needs to do, and then just expose the last piece of work that does the work that we need to do. And so in this case, hey, my logger is now just a function. It takes a string and returns unit. So that's an example of taking advantage of this partial application. It's a way to use functions as your kind of compositional unit. You don't need to define a full-on object in order to kind of pass functionality around. You can just pass a function around. And if that function needs to be aware of other pieces of data, you can use partial application to bake that functionality into the function itself. And so this is why in F#, the function is what we often default to using functions as our way of composing logic and putting things together. And it's because we can bake a lot into a function using partial application. Now, related to that is the idea of a closure. And closures are important to talk about because I wasn't really aware of what a closure was until years into my F# journey. But then when I saw it, someone pointed out oh yeah, that's a closure. I'm like, what the heck is a closure? I'm like, oh, well, that's good to know. So let's talk about what a closure is and say, hey, let my closure. Well, first let me say something that's let's say hey, my chicken name, and it's gonna be Clucky. I know, the animals. We're back to the animals, something silly. And I'm gonna say let my closure. And what should we, let's just put in n. Say it's an integer. And so now I'm going to have this closure, and I'm going to say hey, I want you to return a string, which is, I'm going to put my chicken name dash n. Okay, what is going on here? Why am I using the term closure? A closure is a function that is capturing some amount of surrounding scope. I hope I am saying that correctly. But the idea is that it's closing over the scope. It's having to capture something about the local scope. And what's happening is what you'll see here is, hey, my closure is a function, but it is using my chicken name. My chicken name is a string that is defined outside of outside of this function. Because my closure is also a function. Closures are like a subset of functions. My closure is a function. It has this one parameter n, which is an integer, but it is also capturing some state out here. And that state is my chicken name, which is Clucky. And we can go ahead and define these. go ahead and fsharp was like, okay, yep, we have defined my chicken name. It is clucky. We have defined this function called my closure. It is something takes an integer c. So okay, my closure, and I'm actually gonna do. I much prefer this way. So my closure, and I'm gonna put 10 in. Like, oh, okay, and it's going to return a string, and it's going to be clucky -10, which is exactly what we expected here. Cool. That's great, Matthew. Like, why do we care? Well, this is some like really useful functionality sometimes. Just being able to use parameters that are in scope is a very nice functionality. It's great that I don't have to do this, where name is a string, and then I'm having to do this. It's like, okay, well, now I'm going to call it with my chicken name. Like, yeah, that's a little bit of a hassle. So if you know you have this case where like, I'm defining this closure, I'm always going to be using this parameter that's been defined outside of this. Great, go for it. Do that. And you know what? Most of the time, that will not be a problem. And the reason it won't be a problem a lot of the time inside of the F# language is because the defaults of F# are immutable. So my chicken name is a string. String is an immutable type in the .NET runtime. So there's no risk of this changing on you. Here's where things get interesting. What if this is immutable? And say like, okay, this is now like, what is going to happen here? Because now my closure is capturing a mutable. And we haven't gone into mutability inside the F# language because I'm going to have a whole video just talking about, probably a few videos, just talking about mutability. But I want you to think about the fact that, yes, in F#, most of the time, the data structures and data that we are working with are immutable. But we also exist on the .NET runtime. .NET collections and system.collections.generic, like those are mutable collections. And so if you were capturing a mutable value in your closure, it would be very easy to get some brutally difficult bugs that you would have to debug. Now, again, since F# is immutable, you're probably not going to have to deal with this. But let's go ahead and do the thought experiment and see what's going to happen here. So clucky 10, what happens if I say my chicken name equals Charlie? What's going to happen now? Now, when I call my closure, it's saying Charlie-10. So what do I want to take away? What do I want you to take away from this? Functions are incredibly powerful. They're very useful, and in a later video, we're going to see closures utilized a whole lot more. But I want you to develop an intuition very early on. When you see this, when you see a function capturing surrounding state, like take a moment to look at your code and say like, okay, am I capturing anything that might mutate underneath me? Probably not, but I want that to kind of trigger something in your head, like, whoa, okay, like think, like warning. And this is why in my theme for VS Code and also in JetBrains Writer, mutable, anything I declare as mutable kind of gets this like burnt orange reddish color because it's like, hey, warning, pay attention. So for me, there's a very quick visual indicator like, ooh, I'm defining a function, but it's a closure and it's capturing something that could be mutating underneath me. Oh, like I'm not saying that's just a bad idea straight up front, but if you know you're going to do something like this, I would strongly encourage you to do something like this, like let not closure, and have it say like, hey, name string, and then n and equals, and then essentially the same thing. Like I'm just gonna straight copy and paste this, and I'm changing this to name. But if I would strongly encourage you in this direction, and this is often just good practice in general when writing functions. And this is, some people really geek out about pure functions. This can be incredibly convenient. I'm not saying it's wrong. If you're going to do this, take a moment and see that if you're capturing anything, that it is immutable data. If you are potentially capturing mutable data, I strongly encourage you to use this approach because it will protect you against Heisenbugs, which is the idea of like a bug that isn't necessarily easily reproduced and doesn't happen every single time. I love that term. So I strongly encourage you in this direction. Don't have closures that wrap mutable data. You might have a really strong use case for that. I would strongly encourage you to see if you can design around it, design away from it. Again, this is kind of coming from my experience and save you some scars that I have. So that is what I have for you today, just talking about, hey, partial application and closures, like ways we can parameterize functions and give them more complex functionality. We got another video where we're going to be talking about functions here real soon. So what would really help me is if you provided feedback on, Matthew, you know, this was clear, but man, this was really confusing. Like, hey, I need you to cover this more. Like, what are the things that are clicking with you and what things are really difficult? I'd really appreciate knowing because, again, I'm making this for the F# community, and I want to make F# an incredible place for everyone to work. Thank you very much. You have a great day.